moving on to problem number 15. This appears to be this is a uniform distribution. It says that the heights of trees are distributed uniformly between 5 and 10 inches. Find the probability that a randomly selected cedar tree will grow less than 8 inches in a given year. Okay, so the way that I like to think about this, I like to think about it like it was on a number line. Okay? To me, it just makes more sense in my head. So here's 5 inches, 6 inches, 7 inches, 8 inches, 9 inches, 10 inches. And it says less than 8. Okay, so that would be all of this. So how many different inches? We have 1, 2, 3, 4, 5 of those. And less than 8 would be 1, 2, 3 of those. So that's 3 out of 5. So that's your probability that at any given year it would be the tree would grow less than 8 inches. All right, so it's 3/5. All right, on this problem, it's going to be easiest just to use the table. Find the area under the curve to the left of z equals 2.11. You see there's a table button here. There's also buttons down here. That's because I had this table button added for all of your questions. So either one is fine. It's just we need the negative infinity to positive z. And in the problem it said to the left of 2.11. Remember, to the left is how our tables work. That's how they're drawn. So that's how they're made. So 2.1, and then we got to get to the ones column. I didn't even look. Okay, so it's this one right here. So 2.11. All right, so the probability, the area to the left of z equals 2.11 is 0.9826. All right, find the area. Okay, find the value of z such that the area lies to the right of, or such that 0.12 of the area lies to the right of z. All right, so what are we talking about? Graphically, we have our, this is number 17. We have our bell curve, and we want to find a z. It gives us the area. It says 0.12 lies to the right. So that would be an area of 0.12. We want to find what is this z-score. Well, remember, our tables don't give us, if we look up a z-score, that gives us the area to the left of that z-score. So what I need to do is I need to go to my table. I need to say 1 minus 0.12, that would be 0.88. So I'm looking for an area closest to 0.88. I'm not looking up a z-score of 0.88. I'm looking for an area in the table closest to 0.88 as I can get. All right, so let's see. If I had to guess, I'm going to say that was on the right side, so that should be a positive z. All right, so we're looking in here as close as we can get to 0.88. And that'll be our z-score. All right, so 0.8, that's 0.86, 0.86, 0.87. All right. So that's about as close as we can get, 0.8810. All right, 0.8810, and that will be a z-score of 1.18. 1.18. All right. Moving on to problem number 18. The life of light bulbs is distributed normally. The variance of the lifetime is 400 and the mean lifetime is 540 hours. Find the probability of a bulb lasting at most 560 hours. So that's important. At most 560. That means less than or equal to 560. So we want the probability that x is less than or equal to 560. We were given the variance. Remember, we don't use the variance a lot. We use the standard deviation. So if we're given the variance, to find the standard deviation, take the square root of 400. Square root of 400 is 20. All right? And so we're going to figure out this probability by coming up with a z-score and then finding the area under the curve. And since it's a less than problem, we're going to go to the left of the z-score. All right, but what was our formula for z-score? Remember, it's x minus mu over sigma. So our x is 560. The mean that they gave us in the problem was 540. That was given. All right, so it's 560 minus 540 over, now this isn't a central limit theorem problem. It didn't say that they took a sample and then there was a number of items that they took. It just gave us the standard deviation, and we're figuring out the probability of getting one of these things. So it's just divided by the standard deviation. We don't have over the square root of n like we've had in so many other problems. And we'll do that in some problems in just a second. All right, here's how we find a z-score. X minus mu over sigma. All right, well that looks like that's going to be 20 over 20, which is 1.00. Remember, z-scores we take to 2 decimal places. All right, so if this is a less than problem, all right, here's our bell-shaped curve. Here's our mean. Here's where x is equal to 540. We'll have a z-score, one standard deviation to the right, all right, of 1.0. So if we look up this value, this will give us less than or equal to. It'll give us everything to the left. So that's what we want to do. We want to go to our, make sure you click the right one, the negative infinity to z. And then we want to go to 1.00. So this is the 00 column. Scroll down. 1.00. 0.8413. So that's the probability. 0.8413. Let's look at problem number 19. A quality control expert at Glowtech Computers wants to test their new monitors. The production manager claims they have a mean life of 95 months with a standard deviation of 5 months. If the claim is true, what is the probability that the mean monitor life will be greater than 96.3 months in a sample of 84 monitors? So this is the central limit theorem problem where you have multiple items. So you're taking 84 of these things and you want to know what's the probability that the mean monitor life will be greater than 96.3. Now it gave us a standard deviation. It gave us the claim. This is the population mean. So we just need to figure out a z-score. So let's see, what all did we have in that problem? We had the mean claim. What was that? And you can think about that can be x bar or whatever you want to call it. We can just call it x if we want to. We'll just call it x. All right, so that's what we're trying to figure out a probability about. All right, we want to know the probability that x is greater than that. And we were given the sample mean, no, we were actually given the population mean was 95 with a standard deviation of 5. Also, we were told that the sample size is 84 monitors. So this is a central limit theorem problem. So we're going to say x minus mu over sigma divided by the square root of n. So it's 96.3 minus 95 over 5 divided by the square root of 84. All right, so work this out. If you punch that in your calculator and work it out, you're going to get 2.38 when you round. All right, and since this is a greater than problem, we can't just take the value from the table. We're going to have to say 1 minus whatever area we get when we look up 2.38. So let's look at the table. Tables, standard normal table, negative infinity to z. All right, and we want to look up 2.38. So 2.3. I gotta scroll over a little bit. 8. All right, so we want to say 1 minus that, 0.9913. So 1 minus 0.9913, that's going to be 0.0087. Okay, so that is the probability. Not even 1%. Okay. Problem number 20. I see that I have a percentage, so this is going to be a proportion problem, and we are talking about probability. So remember, our formula is a little different finding the z if you have proportions. Let me refresh your memory. So if we have proportions, z is going to be equal to p minus p hat divided by sigma sub p hat. Okay, and sigma sub p hat, you have to find it. That's equal to the square root of p times 1 minus p divided by n. All right. So usually that's some crazy decimal because you have to do that and then take the square root of it, and it's a really small decimal. We'll see what it is on this problem. So let's write down everything that's given. All right, so this is the claim. 47% of doctors in America are dentists. And then here's our sample size, and here is our probability we're trying to find. We want to know if you select 793 doctors, what is the probability that the proportion of doctors who are dentists is less than 50%? I mean, if I say that to myself about 1,000 times, I'd probably be able to, use some math sense and figure it out. It's that kind of deal. If 47% are, and I take almost 800 of them, that's a pretty big sample size. There's probably a really good chance that less than 50% will be, of the doctors will be dentists. So we'll see. I'm just guessing though, going off of what's there. All right, so we need to find sigma sub p hat. And the way we find that, remember that original claim, it says suppose 47% of the doctors in America are dentists. So 0.47, that's our p. So it's 0.47 times 1 minus 0.47. Well, 1 minus 0.47 is 0.53. And then divided by, it said there were 793 in the sample. All right, so if you multiply, then you divide, then you take the square root, you're going to get, and I like to carry this one out kind of far, 0.0177235. I carried out kind of far because I'm going to use it in a different formula. So if I only rounded this like to one place or two places, I would get a big margin of error when I plug it in. So if you've ever wondered why do I carry stuff out so far, it's because I'm going to use it somewhere else most of the times, and I don't want to create a large margin of error when I plug it in. All right. So p minus p hat, that's going to be what? So 47%. Okay, so it's going to be 0.5 minus 0.47 over, and it may be that this was p hat. You can do, I mean, it's It's basically the same thing, so don't get confused here. The problem you work out, I promise you work it out like this, you're going to get it right. But you say p minus p hat divided by that decimal that we got, 0.0177235. When you do all of that, let's see. Well, I've done it on this paper over here, so just be careful. Do this first, and then type in all of these digits carefully. And I got 1.69. All right, this was a less than problem. So I'm going to actually be able to take this, the area that I get out of the table. So, the tables, standard normal. All right, I'm looking up 1.6, and then I got to scroll over to the nines column. 0.9545. 95.45% or 0.9545. That's your answer. Okay, and I'm looking at it right here. I'm looking at the answer key. That's what it has. So, hopefully that didn't confuse you too much. If for some reason you reverse these two up here, you're just going to get the negative of this. And when you look up the negative of this, you're going to get a really small decimal. So if you have math sense, it's not going to really make sense. Like, it shouldn't be a small percentage. If we take if I was to tell you that studies have been done and that 47% of doctors in America are dentists, and I said, okay, what if I took about 800 of those? What's the probability that less than 50% of those are dentists? Well, it should be a pretty good chance. If almost half of all doctors are dentists, then it should be a pretty good chance that less than 50% are dentists out of a group of 800. All right, number 21. Let's see what that is. All right. Consider the value of t such that 0.01 of the area under the curve is to the right of t. Select the graph which best represents the given description. All right, area under the curve to the right of t. If this is t, that shaded part, that's to the right of t. It's got to be that one. Let's look at the others, though. This one, it's shaded to the left. This one is shaded on both sides. And this one is shaded in between the two. And the problem definitely says the area under the curve is to the right of t. Well, that's it. It's got to be that one. Now, this is step 2. So it says, assuming degrees of freedom is 6, select the t value from the table. So the degrees of freedom is 6, and the area 0.01. So 6, not 0.1, so not this column, 0.01. All right, so there's your, let's see, that was 5, 6. There's your answer. So 3.143. Be careful. You see how easy it was for me to select the wrong one? This column, this row. That's the answer for sure. Alright, a newsletter publisher believes that over 70% of the readers own a personal computer. Is there sufficient evidence at the 0.05 level to sustain the publisher's claim? State the null and alternative hypothesis. So that's all we have to do is state the null and alternative hypothesis. So we want to write this stuff down. We want to write the claim down. And then we'll write the opposite of the claim down. And then the one with equality will be our null. Alright, so let's write these down. This is problem number 22, I believe. So it said a newsletter publisher believes that over 70% of their readers own a personal computer. So that will be a proportion that P is greater than 0.7. That's 70%, right? 0.7. or 0.7 if you want to write that. What would the opposite of that be? P is less than or equal to 0.7. The one with equality, we change it into equals 0.7. All right, and so that has to be which one? That's our null hypothesis. The other one, the alternate hypothesis, that's P is greater than 0.7. So the one with equality, you change to equals, that's the null. The other one, whatever's left over, which is this one, that's the alternate. All right. And there's a keypad, I believe, if you want to type the different symbols. I think you can just use the P button here, though. You don't put P hat for sure. But the greater than and less than symbols or equal to symbols are all here in this keypad. All right. This problem, find the value of the test statistic. Okay, so to find the value of the test statistic, we just follow the formula, right? What all are we given? We have a claim up here of 54.5. We have a sample size of 220 bands with a mean of 54.2. We're also given a variance. Now, we're not given the standard deviation, we're given the variance. So we have to find the standard deviation, and then we're going to find the value of the test statistic rounded to 2 decimal places. All right, I think we can do that. Since we were given a sample, it was a large sample though, so you can think of this like a z-test statistic, right? So we were given a claim of 54.5, and we were given n of 220. We were given a sample mean, so this is our population. We were given our sample of 54.2, and it says assume a variance of 4.84. So variance of 4.84. So we need to take the square root of that. When you take the square root of that, you get 2.2. All right. So to figure out the test statistic Z, we want to say x bar minus mu over sigma, or the standard deviation, divided by the square root of 220. All right, so subtract the top. Then what I like to do if I'm using a calculator is I will multiply that by the square root of 220 and then divide by 2.2. When you do that and you round to 2 places, you're going to get a negative value because of the numerator. You should get negative 2.02 when you round to 2 places. Negative 2.02. All right. Moving on. The manufacturer, let's see, of chocolate chips would like to know whether its filling machine works correctly at the 449 gram setting. It is believed the machine is underfilling bags. A 33 bag sample had a mean of 446 grams with a standard deviation of 27. Assume the population is normally distributed. Levels of significance of 0.05 will be used. Specify the type of test. Oh yeah, so this is going to be really easy. Are we trying to figure out, is it a less than problem, is it a greater than problem, or is it an equal to problem? Less than left-tailed, greater than right-tailed, and not equal to two-tailed. So really to do this, since this is a study, we have to look at the alternate hypothesis. So, but the easiest way, let's see, is going to be, it believes that the machine is underfilling the bags. Underfilling would be less than, so less than would be left-tailed. You don't even have to write them down. If it's a less than problem, it's going to be left-tailed. If it's a greater than problem, it'll be right-tailed. And then if it's you're trying to figure out if it's not equal to something, then that's a two-tailed. All right. Last problem, number 25. All right, so number 25, we have to do the entire thing and then figure out, do we reject or fail to reject the null hypothesis? All right, so I need to write everything down. All right, so let's start with the null and alternate hypothesis. So let's see. We're trying to figure out if the claim is that it's more than 53%, the residents who favor annexation. So probability is greater than 0.53. The opposite of that is less than or equal to 0.53. The one with equality, that will be our null hypothesis. So that's our H sub O. So the other one, this is our alternate hypothesis, H sub A. This is where we tell if it's right-tailed, left-tailed, or two-tailed. And of course it's right-tailed because it's greater than. All right. So there are a couple of different methods you can use. I would say if you really understand the p-value method, that'd probably be the quickest way, because all you do is take the significance level. This was given in the problem. And if we can figure out the area or the p-value for this, figure out a z-score and the p-value that comes from that. And let's see, if our p-value or our area is less than that, then we will reject the null hypothesis. If it's greater than 0.1, we will fail to reject the null hypothesis. So let's see. What do we have to do? Well, these were proportions. So remember, it's this thing right here. And remember, it's sigma sub p hat. All right. So sigma sub p hat, that's going to be 0.53 times 0.47 divided by 1,000. All right, we take the square root of all that. When you do that, you get 0.0157829. All right. So again, I like to carry that out a little ways because I'm going to use it in this formula over here. So over here is we have 0.57 minus 0.53 divided by 0.0157829. All right. So in this formula, you can think about it p hat minus p. I think I wrote it backwards last time, but I mean, you should get a positive z-value out of this, and we will. You'll see if you punch that in your calculator, you get 2.53. So here's the deal. To find the p-value, it's going to be the area to the right of this, since it was right-tailed. Okay, if it would have been left-tailed, it would be the area to the left, but it was right-tailed. So we got to look at this table, standard, normal, z. 2.53, and remember it's going to be the area to the right of this, 2.53. So the area to the right of this, of 0.9943. Area to the right, remember you got to say 1 minus that 0.9943. That's going to be 0.0057. Is this less than the significance level or greater than the significance level? This is definitely less than the significance level. So that means we are going to reject the null hypothesis. And we are done. Good luck on your final. Email me if you have any questions.